going through this morning, and a great example of a sector area is a slice of pizza. Of course, there's many more examples. It could be a slice of pie or whatever. And so if you want to visualize that for this lesson, anytime you have a circle and you take a piece of that circle out evenly, that's what a sector area is. Okay? And so anytime you take a slice of the circle's area, that is considered a sector. So let's take a look and see how we can get the formula. I'm going to tell you right now this lesson is very similar to arc length. Okay? What is an arc length? It's a piece of the circle's circumference.
Oh yeah, I didn't get any of those yesterday.
A sector is, well, we went over that. You should have known that. A sector is a piece of the circle's area. So let's take a look and see what it looks like.
You want us to draw this big circle?
Okay.
Good talk.
So there we have a sector. Let's say we want to figure out the area of this sector. Well, first of all, let's write out the formula for the area of a circle. I'll go back to that in a second. Of course, you can draw that on your paper. It's not hard. What is the formula for the area of a circle?
A equals
Pi?
pi whole square.
Pi squared. Okay. Now the reality is we want to find a certain percentage of that, right? It's a part of the area. So let's go back to the diagram. Basically all you need to know, let's just use a specific angle here. Let's say this is a 30-degree angle. Okay? Well then, the area of that sector would just be based on that angle out of 360, just like the arc length is based on 360, right? For example, if you had 180 degrees, the length of the arc would just be half of 360, right? 180 over 360.
Is this assignment pretty easy?
So, yes. So for this particular one, and let's just say that, well, it doesn't matter, we'll go back. We would take a percentage of that circle and multiply by its area, and that would give you the area of the sector. Okay? Just to be a little bit more concrete, I'll go back to that in a second. Let's say the radius was 10, just to be simple. So basically what this would amount to is you'd have 30 over 360 times pi 10 squared. So just like arc length, except you're taking a fraction of the area instead of the fraction of the circumference. That's all it is. So let's go ahead and write out what the formula is going to be in general. Of course, the angle is not always going to be theta, and the radius is not always going to be 10. So from there we can come up with a simple formula, the general angle and radius. So it's going to be theta over 360 times pi r squared. Don't know what happened there. I'm just going to fix that. This is our formula for sector area. So again, it's just a fraction of the actual area.